All right, let's talk about something that's probably in your kitchen right now. Something we all use but maybe don't totally get. The microwave. We're going to pull back the curtain on this amazing box and break down the science of how it heats your food so incredibly fast.
I mean, really think about it. You pop something in, hit a button, and boom. A minute later, your leftovers are steaming hot. It kind of feels like magic, right? Well, it's not. It's just some really, really cool physics. So let's get into it.
Okay, so the whole process kicks off with something we can't even see. The secret ingredient here is a specific type of invisible energy wave. And what's wild is that this is just one member of a huge family of energy that's literally all around us all the time.
Yeah, that term electromagnetic radiation sounds super intense, doesn't it? But don't let it fool you. It's everywhere. The light that's letting you see right now, that's part of it. The radio waves bringing you music in your car? Yep, that too. Microwaves are basically just cousins to light and radio waves.
So deep inside that microwave box, there's this little powerhouse called a magnetron. Think of it like a tiny wave cannon. It creates these microwaves and just blasts them into the oven. And those shiny metal walls, they're not just for looks. They act like mirrors, making the waves bounce around like crazy, filling that whole space with energy. Okay, so we've got all this energy ricocheting around. But how does that actually get into your food and heat it up? Well, the answer lies in something super, super common, something that's in almost everything you eat.
And that special something is? Water. Plain old H2O. Water molecules are the real heroes of this whole story. They have this one unique property that makes them go absolutely wild for microwaves. They're polar.
So what in the world does polar mean? Well, just think of a water molecule as a tiny little magnet. It's got a positive end and a negative end. When the microwaves create their electric field, these little water molecules try to frantically line themselves up with it, kind of like a compass needle that has to point north.
And this is where the action happens. The microwaves basically grab onto these little water magnets and start shaking them back and forth, billions of times a second. It is absolute chaos at a molecular level. All that frantic spinning and bumping into each other creates friction. And what does friction create? Heat. Lots of it.
And this, right here, is the most important thing to get. The microwave oven isn't actually heating your food. Nope, it's way more clever. It's telling the water inside your food to heat itself up. The food is literally cooking itself from the inside out. How cool is that?
So now that we have the science down, we can finally solve some of those classic microwave mysteries that drive us all a little nuts.
You know exactly what I'm talking about, right? You heat up last night's pasta, and one bite is like the surface of the sun, while another part is still ice cold. What is up with that?
It turns out, as those microwaves bounce around, they create these patterns of energy. You get hot spots with a ton of energy and cold spots with almost none. And the fix? That simple little rotating plate. The turntable is a genius solution because it moves your food through all those different spots, making sure every part gets a turn in the heat. And that's also why stirring your food halfway through is always a pro move.
Okay, let's talk about the cardinal rule of microwaves. We were all told as kids, do not put metal in there. But why? What's so dangerous about a fork or a little bit of aluminum foil?
Well, remember how food absorbs the microwaves? Metal does the exact opposite. It reflects them, like a mirror. And that reflected energy gets super concentrated, especially on sharp points, like the tines of a fork. That energy builds up so much that it can actually leap through the air as a spark, a little lightning show in your oven that can seriously damage the machine or even start a fire. So, yeah, bad idea.
All right, mystery of the hot spots? Solved. Mystery of the metal? Solved. Now let's talk about the microwave's real claim to fame, its incredible speed.
Think about a regular oven. It has to heat up the air. Then the hot air heats the outside of the food. And then that heat has to slowly creep its way to the middle. It takes forever. A microwave just skips all that. The waves dive right into the food, generating heat everywhere at once. It's a fundamentally more efficient way to get the job done.
And that incredible efficiency is why you can go from a cold plate of dinner to a hot meal in just 90 seconds. It's a piece of tech that completely changed our relationship with time in the kitchen.
So when you break it all down, piece by piece, you realize what's happening inside that little box on your counter isn't some kind of wizardry at all.
It's just really, really clever science. It's taking a fundamental principle of our universe and applying it to solve a very common problem. I'm hungry and I want my food hot, right now. And this sentence just perfectly nails the whole thing. You're using invisible waves to make tiny molecules dance, And that dance transforms pure energy into the heat that warms up your food.
And it kind of makes you wonder, doesn't it? If something as simple as heating up leftovers is packed with this much cool science, what other bits of everyday magic are hiding all around us, just waiting for us to get curious and ask, hey, how does that actually work?